Ben,
Three
what's your
Bens.
background? Talk to me real quick.
It's Ben Franklin. There's 3 Bens.
What a
See?
dork. I love it.
Boom.
I love it.
We got some Benception going on here. So
Yeah. We
Wicked.
have to keep it very, very Ben focused, right?
I love it. Well, I'm gonna just let you guys kick off and get started. Thank you so much for joining us, for coming to present to us.
yeah, awesome. Can you guys see my screen all right?
Yeah, we can.
Awesome. Is it showing the video on there too? I can't.
You're a little face in the top for me, and I think
Okay.
when in the recording you'll be a little sidebar, but it's not overlapping your slide.
Yeah, I'll take those out so that they're off the slide. Cool. Yeah. So thanks, Jay, for the invite. We're excited for this meeting. I'll just introduce myself and let Ben introduce himself. And I can call him Ben because that's not confusing. You might have to use our last names to talk to us. So my name is Ben.
Right?
That's right.
Yeah.
My name is Ben Ainscough. I'm in the product development group at Domo, and I lead our AI and data science product development. I've been at Domo for about 3 years, 3.5 years almost, and really excited to talk to you about data science and some of our data science products and hear your questions. Ben, do you want to go ahead?
Yeah. Hi, everyone. Ben Schein. I think I know a lot, not all of you guys. I try to be plugged into the dojo and the user group and stuff. But I am a former Domo customer. I'm actually coming up on 3 years at Domo. Before I was at Target. And at Domo, I serve as Vice President of Data Curiosity, and I work for Darren Thane, our Chief Technology Officer, and really sort of describe my role as a data culture enthusiast, not enthusiast, coach, and really just thought leader around how do we look at data and how we work with our customers and talk publicly as really an evangelist around these topics, and hopefully sometimes take those learnings and bring it back to product to work with Ben and other great people on the product side about how that works. So I'm excited to be here and get to talk with a fellow Ben here.
Yeah, awesome. Thanks, Ben. So we're excited to talk to you. We'll be kind of switching back and forth, and feel free to interrupt with questions. And while I'm talking, like one of the panelists, feel free to interrupt me if there's a good question as a segue. So we wanted to talk about how to be pragmatic with data science. A lot of times, like your AI or data science investments at your company turn into research expeditions that are nothing, that aren't good for anything other than PR. And PR is fine, but PR only helps for so long. And so we want to talk today about how the Domo platform can enable pragmatic value for your business, and how you think and structure about your problems, and some of the features within Domo to make sure that you're delivering that pragmatic value. And so we'll talk about a lot of how you frame the problem, how you interact with your people, and then the Domo components that can help with that. We'll share some customer examples, and then we have a quick demo that we'll go over. So that's our agenda for today. And we're just excited to talk to you guys about that. So getting right into it. So if you really think about what the purpose of data science is, or why we're wanting to use this, we want to accelerate the intelligent action, right? With Domo at its core, you have intelligent action baked in, right? Like that's a key value proposition of the time to value, that you can have intelligent action. But we're adding math, machine learning, statistics, whatever technical component you're talking about in the data science sphere, to accelerate that, to get better knowledge, better insights, and maybe even make those decisions faster in the case of an automation example. And those actions should result in like the typical things that help your organization, whether that's increasing your revenue, decreasing your costs, saving you time, or just making your people feel good. And so the first principle that I'd like to convey as you're thinking about a data science workflow, and many PhD data scientists, like from my years in academia, like struggle with focusing on the so what and getting distracted by a technicality. And so if you can always go back and answer the question of how is this analysis or this pipeline that I'm doing accelerating an intelligent action that would result in one of these 4 outcomes, you know that you're on the right track. And data science is so powerful. You can be doing so many things that aren't related to this. And so that's why it's always great to have that as a caveat and a reminder. And so when we think about that, like, well, how do you think about intelligent action and how do you accelerate it? Because the problem framing and formation and how you map your data to that is like the central limitation, or at least that's my thesis, for achieving that pragmatic value with data science. And so I think of 2 main personas that within an organization, and this can be anyone. Sometimes they're the same person, sometimes they're different, but this is just kind of the role and decision making that they take on. So you have the decision maker who's actually going about and making the choice that results in the increased revenue or decreased costs, or who has that final say. And you have a facilitator that helps enable better decisions to happen faster or whatnot. And I kind of like these images because you have the decision maker here that is using what's in his head and his knowledge and his intuition to make those decisions. And you have this image that shows like all these clouds connected to all this data that's being distilled into something that can facilitate that decision maker. And so I basically have some very simple definitions. Like, a decision maker is going to use knowledge to make decisions, like I talked about, and they're going to ask questions, right, so that they can result in that acceleration of intelligent action. And then the facilitator uses data to create knowledge, as illustrated in this image, and then helps answer those questions. And the thing to remember that I think makes data science in particular, and even just data analytics work difficult, is that a decision maker is interacting with like knowledge and concepts and ideas that are often represented by data, but not exclusively that way. However, when we, especially as a data scientist or data analyst role, we often function more as a facilitator, and we're more steeped in the data. And data isn't necessarily stored in a way to distill knowledge. It's stored in a way for our applications to run the way that they do, right? So it's stored so that you can have the speed to return a query at a certain time for an application. And so in many ways, a decision maker and a facilitator can talk past each other when a facilitator gets data centric and data focused, and a decision maker gets like knowledge focused, and they're talking about the same terms but can mean completely different things. And so that's extremely helpful in your knowledge formation, to kind of recognize when you're in each role and how you can translate and make sure that you're driving that intelligent action. And so when we talk about data science explicitly, it's enabling this process to create that knowledge, right, to help those decisions happen. And at the end of the day, there's 2 terminal paths to the analysis that happens in data science. One is, we want to know why something works the way it is. We want to understand causality, right? That's really hard to get to typically. More often than not, with our analysis, we settle on an association or a correlation that's just, it's on the road, it's on the mountain to causality. But then there's also another task to say, like, well, I just want to automate something. I can create a machine learning model that can predict something with the same or more accuracy than my current process. And I can just, I can trust that process is right. I don't know how the decision is being made, but I just trust that process. So I'm going to just let that make decisions for me in my behalf. So a voice assistant is a good example of automation. You could have people transcribing like Siri or Alexa or Google Assistant, but it's much more tenable to use that with a machine learning approach. And so just real quickly, like at the end of the day, whether we're talking about causality or automation, like this knowledge is obtained to accelerate the intelligent action when you can apply the information from a sample to a population. We almost never are able to get the full picture of what a population is and what that data is. And in some cases, we'll get samples like it's illustrated in these little charts, where like we have the mean of this distribution here, but the sample's mean is a little bit different, right? And so that might not generalize if we use this sample to infer something about the population. But whether it be causality or automation, you're trying to infer from samples that you can measure, that you have the costs and resources to measure, to a population. And so those are just some like very high level ideas that get people very tripped up as they try to achieve pragmatic value with data science. And then specifically, like what are some of the things that we would use? So let's just talk about some supervised machine learning techniques and unsupervised machine learning techniques. And so in supervised machine learning, you're using data with outcome labels. So you have historical information from a sample to learn the process that you can apply to a population, right? So what the machine learning is going to learn is the algorithm or the way that it should route new data to make decisions. And so some examples of that is if we have churn, if we want to predict when an employee is going to leave or when a customer is going to leave, that's a classification problem. We can look into our historical employee database or customer database and see when they have left and look for inputs that would be indicative of that and train machine learning algorithms to make those predictions. Like demand or sales forecasting problems, that's a regression problem where you're predicting a numeric value and you can use the same historical approach. There's also unsupervised machine learning where you're using data without outcome labels to do the same thing from a sample to learn a process that can be applied to a population. So that, like, some good examples there are customer segmentation, where you want to just find some patterns of clusters in the data and use those clusters for marketing or some other activity, some other analysis. Or fraud, you want to find an anomaly so you can tag a fraud and save your company some lost money or revenue. And so with that's my general like overview and introduction to data science. There are substantial resources into the statistics and math and machine learning that are readily available online and you can apply to the Domo platform. But if you don't approach those with the problem framing that I've begun to outline, you can trip yourself up. And so with that, I'm going to pass over to Ben, who has some other things to consider when you're applying machine learning and AI to your business.
Thanks, Ben A. I'll try to keep everyone clear, although they should deduce, right, which Ben it is when we're saying it. So I just wanted to share a little bit, and again, all of this is sort of based upon our experience doing this work with Domo, doing this work with our customers, doing this work when I was at Target. And so I want to talk a little bit about sort of the human side of how all this comes into play. And obviously Ben talked about some of these personas that we have out there. And right, I often talk about it as like, you know, there's successful artificial intelligence requires human intelligence, right? Like that's part of how it works. And so often, you know, I often make the joke, it's like the problem is we have all these humans involved, right? Because they have emotions and they're tied to things. And so often we do all the good work that Ben said, we might even have listened to them and talked to them, but then sort of like this horde of people are coming after you, right? It's, you could click, I forgot there's all this animation, Ben, or I don't know if I have control. There you go. Yeah, you did two more. You can keep them. You can bring them all up. It's fine. All right. So like some of the things that I think often happen when you approach with sort of this data science or this AI ML. So one is fear, right, which is a really hard thing to deal with, right? People are afraid for their job. They're afraid for their relevancy, their worth, the value they bring to something. And that gets really hard because, right, it's hard to argue with that, but you need to be cognizant of that in terms of how we think about the human side. I think there's often sort of a challenge, right? And this is where I think Domo does come in terms of how much detail can we expose, how can we use them to sort of like encourage challenge, because that helps us make better, right? But because, and some of this is driven by the fear, but because of that fear, you start saying, oh, this one data point is wrong, or that would never happen. This is showing a negative number. And then it's just that one challenge just sort of does everything, and that leads to sort of this dismissive nature, right? Of like, right, if there's one thing that's wrong or one time when the model, like the first version of a model isn't always going to be more accurate than a human decision, right? The idea is like, how do you train it and make it better? But again, they'll find that one, bad result or one time when the model fails, and then it just becomes dismissive. And really, I think in the end, you end up with a lot of apathy, right? It's like, great, you did this. Maybe I'm still getting an Excel sheet email from the model team or a Domo page, but I'm just going to keep on ignoring it and do what I always did, which was, manually input my forecast, or, just make an assumption or do a blanket growth assumption without looking at the detail. And so, I think a lot of our challenge and a lot of how I think Domo at its best really is about getting past these emotions and helping people be able to see the value of the data science we can bring to bear. So just a few things. We go to the next slide. And then we can click through. Sorry, I apologize for the animation. I hate myself for having so much animation in here. These. All right, there we go. So some ways in which I think that we can honor sort of the human intelligence, right, that we need to make artificial intelligence really relevant. So one is really about, and Ben touched on this too, of like, how do you empower users to engage with sort of the detailed output of the machine learning and the AI algorithms, right? How do we make that really work? How do we sort of ask for feedback from the start, right? Again, start the relationship as, we're going to do this, but we need your involvement, in this, and we honor, right? Again, if there is, because if you think about emotions, right, it's not about logic. It's not like this will be better. It's like, look, I understand you're the manager of the store for 15 years. You know way more. Like, tell me what I should understand. Tell me what I need to know about this model in order to make it really come to life, and do it. And even just that approach can really unlock things and make your model better, right? Like, the manager of the store could tell you what they should look at, or say, you know what, whenever school is out, we always see an uptick. So maybe I should look if there's a way for me to put into my model something about whether school's out or it's a vacation from school. Right? Like, those are things that can be really hard to find from a data science perspective, that you need the human side. Right. And so some of that is also like, how do you help humans understand their continued role? Right? It's like, I know we're going to be forecasting this, therefore you can spend less time doing your forecast and more time giving me feedback, or more time coaching your team, or more time, doing the things you enjoy about your job. Now, obviously, if someone enjoys manual work and can't think about themselves as being valuable in a different way, then, that could be a challenge as well. And so the last thing is, I think one of the places where some of those emotions I talked about show up the most is when it feels like you're creating a black box. And I've seen this where like people spend millions of dollars with huge consulting companies, and it's like literally an Excel output with like one row of data per location or region or SKU or whatever it is, and a forecast number, and like a confidence value. And that just feels so untenable. And so one of the things I always think back at, and I think this will get into some of how Domo looks at a target, is right, part of how Domo helps us do this is this combination of scale, of ease of interaction, and then using that scale to sort of empower the team to troubleshoot and get feedback on their own. And so I remember like one of the early on a Domo journey at Target, where we had a data scientist who was doing a lot of the algorithms around product recommendations. So like when you look at a product on the Target website, what else shows up there, right? Based upon your customer and all these things. And so originally the MO was, okay, I do this algorithm, it's running on the website, and I summarize this data, and they used to put it into Tableau. Now they put it into Domo. Sorry, I should have had my do not disturb on. I got a call there. I declined it. You put into Domo at like the division level. So like electronics, beauty, healthcare. And what would happen is then the business or the product team would look at that. Then they'd say, beauty looks funny. They'd go back to the data scientist and say, hey, the beauty numbers look funny for conversion. and the data science would have to go over in a Hive query and look and see what was going on, and then go back and forth and maybe send them an Excel sheet and all these things. And it wasn't a good conversation. It was an annoying thing for the data scientist. But finally, when this data scientist realized, oh, like Domo is more scalable, I could actually load item level information on what the recommendation engine is doing, right? Now, not only are they not bugging me for these things look funny, I can now elevate the conversation, right? So when the team does come to them, it's not this looks funny, it's, hey, we've been looking at the results. We see that lipstick items are performing differently than eyeshadow. Can we talk to you about some things that we've done to change the lipstick assortment recently that maybe should be part of your algorithm, right? So I think those are some of the switches. That's when you start getting this aspect of human intelligence involved. And I think that's where, what I think a lot about these examples, and we can chime in on more and show you some too. That's where like I see Domo really helping to connect those dots and help us overcome some of those emotions that people are going to have when they're looking at automating something, or at looking at machine learning or AI or other data science approaches. So hopefully that is a good foil or adjustment there to what Ben shared. I think it sort of brings a collective perspective for us.
Definitely. It's always important to remember it's much more than just data and algorithms to actually get value out of this data science. And that's where we want to focus our demo. So we can go over like some of the features that are available, and then we'll do a quick demo of the newer AutoML feature. So let me stop sharing my screen so that I can get this all situated and switch my windows and whatnot.
And Ben, just a second. While the gentlemen are giving their presentation for the audience, it would be interesting, I think, for Ben to have, to have that context. Can you, if you are currently doing data science at your organization using the Domo platform, can you just put that really quickly in chat for us so we can kind of see that, what the engagement looks like there? And if you're using a different platform, can you indicate what that platform is? And lastly, if you're not doing any data science yet, but you're kind of intrigued to get started, could you also just really quickly just type it in chat, just so as Ben is kind of going through this, we can get an idea of where you guys are at as an audience.
Good.
Sorry,
Good,
Ben. Go.
Jay.
No, I think that's a great call out, Jay. So we'll let some of these answers come in. Just to see. I'm not seeing anything yet, so.
Well, no worries. Don't wait for it. Just go ahead and we'll talk about it a little later.
Cool. Yeah. So really, like with those lines, I hope we instilled enough of an idea within everyone that everything that goes around the algorithms, which is where most of the attention goes, of like what algorithm should I use, what technique, like all of those things. That's where a lot of the airtime is. However, that only works assuming that you, like most approaches and resources out there, are assuming that you have data that's ready for that, right? Like you have data that's clean and like well processed and well understood, and then it's agreed upon what that represents between like those personas. Like especially is important that the decision maker and the facilitator both like have an understanding there, and then it's aligned to the business problem. But then even after you get that model produced, communicating it to your audience is really important. And so oh, we don't have the data science launch page enabled in this instance. We can get it enabled, but that can kind of, there should be in, I don't know why it's not enabled in this instance, but in all instances as of Domopalooza, there should be, oh, here it is. Sorry, I just didn't see it. So there's this data science homepage, which just really highlights all of the things that you can do in Domo with data science. And so just kind of organizing the features by the way that you would use them. So whether you're preparing your data, discovering your data, you're developing experiments to untangle causality, or you're making predictions to untangle automation, or you're trying to like deploy and distribute, there's resources in Domo for all of those things, and you can kind of go through and see what all of those are. As you may know, there's AutoML and the Python and R scripting tiles that are for sale right now. Jupyter Notebooks is in beta, but we're pretty liberal in who we enable for that. We have some great things planned before we make it GA. And so there's really like a great suite of tools for you to not only do your whole process of making sure you aggregate and agree on what your data is, and then disseminate that to everyone else. And so we can talk about individual features, and feel free to paste in the chat any features that you would like Ben or I's to go over or feedback on. We're going to go over an example with AutoML real quick, but we're happy to kind of talk through questions about Jupyter or scripting tiles or any other data science features as well. So we at Domo use the Domo product as much as in our own processes as just about anything else. And with AutoML, what's really it's really powerful for the data scientists to accelerate their workflow. You can set up and run algorithm much faster with the AutoML interface than having to code up a bunch of things yourself. So if you have a quick idea, you can get that running and get a result back in a couple hours, which might take you a whole day otherwise to set up like a new project environment and copying your code over and doing those types of things. And so for the data science, it's valuable for that, but it's also valuable for the for like those that are or the aspiring data scientists, I guess, those that are wanting to use it and wanting to have some help along the way. And we've had some good success at Domo where this data set that I'm going to show you is an example of a sales prediction problem, right? So if you think about enterprise sales, it's actually modeled about Domo sales prediction, right? So at Domo, we have AEs, we have sales reps, right? They are on teams and they work in different countries, right? That are seeing accounts in different industries that might make different revenues and whatnot. And so we actually like exposed this AutoML feature to an individual in our sales ops team who knows our sales data, our Salesforce data, like the back of his hand. And in a previous initiative at Domo, he and a bunch of others, including our data science team on the analytics side, our internal data science team, spent about 6 quarters to produce some accurate sales forecasts for the to better get a better idea of what our sales picture would look like. And this individual in sales ops, very experienced analyst, but not a data scientist, was able to use AutoML and reproduce a similarly performing analysis in about a day, with a dashboard that can be communicated, keeping in mind all of those principles and whatnot. Now, this is not Domo's data, so this is not going to behave the same as Domo's data would in real life. This is a simulated data set that we custom coded up just for illustration purposes. And so there's some things in here that you wouldn't see in a real data set. It's going to perform much better than you would ever expect a real data set to perform. But if you look at it, like I said, you have all of these rows that describe a sales opportunity. And what you're wanting to predict in this data set is, are we going to win this deal or not? And so with those problems that I talked about, this is a supervised learning problem because this is an output that we can measure, right? That only happens after an action has happened that we cared about. And it's a binary classification output. So this is very similar to a churn use case in some ways of, I just want to know the probability that each of these deals are going to close. And our friend in sales ops was able to identify like, well, these are the input variables or attributes of a deal that I think are relevant to include. And so things like how long was the opportunity open, or how many days was it in stage 1 to stage 3? or what go-to-market motion have we used on this sales opportunity. And so these were things that using beast modes, our friend in sales ops was able to do some custom feature engineering at the data-centric layer. And that's why like all that I was talking about in terms of framing your problem is important, because when you can be data-centric and know your data really well, you can point your algorithm to the factors that are going to be the most impactful. And so we have this data set with one output, and then the rest of the columns are inputs. Then we know it's ready for AutoML. And that's this is the end result of what it looks like. We'll just show you. If we hadn't run this already, when you came to AutoML, you would quickly come to this dialog where you can just choose, I want to see, I want to predict when this deal is going to win. And AutoML is smart enough that that's all you really need to tell it, right? It can figure out the rest. But if you want to be a little bit more advanced, you can choose what the task type is. In this case, it's binary classification. These jobs on the low end take about 45 minutes to run, but can take a lot longer, especially if you have a large data set. So you can tune how many different models you're going to try, which will have an impact on how long the job runs and potentially how accurate of a result you can get. You can get the same accuracy with one as you could with many, but you're more likely to get one if the more that you put in. And then you can also change how you evaluate success on the model side. So for accuracy, you can, or for classification, you can look at accuracy, F1, AUC, and you can look up those values, and the questions we can talk more about why that would be relevant. So I'm gonna just hop away and just assume that I had run that, and we waited the hour or so for it to run. In AutoML, you get this output.
So like it's like a baking show, Ben, right? Where they have the pie already cooked. You're like,
yeah. So this is,
let me go look at the oven. My other oven.
This is my Martha Stewart right here. And so what you see here is that AutoML went through, did this binary classification problem. It ran 25 candidates for me, and candidates include a lot of data processing that we do on the back end in conjunction with the model types and the hyperparameters that we would use. So if I look at this model 9 that was the best performing, like just a call out, if you ever see 100% or 1, like this is the top of the range for that, chances are you probably have something wrong with your data. That's a smoking gun or a red flag typically, but this is a simulated data set, so it's much easier for machine learning to find the decision boundary than in real data, so we don't worry about it. But each candidate has feature engineering strategy that's more like machine learning centric. So it's not thinking about your domain. It doesn't know anything about your domain. It just knows that certain things tend to work well, whether it's encoding strings a certain way or binning categories a certain way or whatnot. It just says, well, we can just brute force and try a bunch of different things. And you can also, we use some smart search techniques to search the hyperparameter space that dictates how well the model performs, right? And you can see that there's 25 different models that were tried, some linear logistic regression and some XGBoost models. And we also are able to see the feature importance values. So what values are the most important? And so this stays open, which our friend in sales ops did some custom feature engineering based on what he knew. So he looked at like what the current date was minus what the start date was, so produce this days open variable. And it's the most important thing in determining whether this is a sale or not, right? And so really quick to train things with AutoML, and you can frame it on all those problems that we talked about. And then you can deploy these. And so I'm going to just go to the one that I've already set up, so I don't have to click through. So here's the sales opportunities prediction. We can look into the ETL, and it's just really simple. So if I click that deploy to ETL button, it would already have this tile configured. If you open it from the data science section, you'll have to select your model in there. But I just take the data that I haven't classified yet, which we just called test. We had a test and a train, and then we can run it through and create a data set which we would have that output to. And then like we can create dashboards that, like, my dashboards are not anywhere as good as the last talk. I'm not a dashboard expert. But here you can see, like, we have the predicted total sales of 298K dollars. And we've won so far 104K of the total, right? And so there's the opportunity within that to kind of where you can go and drill down into why each, like what AutoML predicted for each of those things, right? So if we go into the prediction data set, I didn't get a card made in time for this talk, but when it predicts the data, we have this, well, what is the prediction of what it's going to be, and what are the probabilities of each of those things, which we have some in scientific notation here. So it's either like really, really sure or really, really not sure. So in any case, so that goes over the demo. I'm going to pause there so that we can talk about any other customer examples or anything else. Ben, do you have anything to add to that?
No, I mean, I think just a lot of it, right? It does, like, that end-to-end nature, the fact that, again, if you go with that presumption that it's not just about getting the model right? If it's just about getting the model right, great. I can do that. I can do that in Jupyter on my own. I can do that in Python, all those things. If it's about actually impacting the business, dealing with these emotional reactions, getting people to adopt the output, that's where I think Domo shines, because it sort of brings those things together in a way that lets you empower people, on a sort of different level there. And I think that's a lot of what Ben showed sort of illustrates, but overall, like the need. I would say that the other thing I often use these days is I talk about that sometimes, like, low code and no code solutions piss off high code, right? I think that this is part of what we're trying to do, is to say, or if we use words like BI leverage. What does that really mean? Well, to me, it means, like, look, I have data scientists and engineers that are high code, that have really great resource and knowledge and ways to apply this, but I also have really good low and no code resources, and I don't want those people working in silos. I want ways that I can sort of combine that and continue to push the organization together forward. And a lot of times we sort of end up siloing it, right? It's like high code stuff goes on over here, low code stuff over here. If you want to know anything about the high code, like Ben was showing, I have to be a high code engineer, right? I need to be able to do that stuff. And that's just very inefficient and not the way forward, I think. So it's part of what makes me excited when I see people being able to do these kinds of things in Domo.
We had a couple questions come up in the Q&A from Marta Matos. I think it's a little bit specific for the general audience, but Ben Ainscough, can you answer that relatively quickly?
Yeah, we can take those, and we have about 10 minutes left, so we could talk about. I think it might be best if we just take whatever questions. If there aren't questions that come in, we can just talk about more customer use cases that are there. So feel free to add any other questions you have about getting started with data science, how you can be pragmatic with it, or even more technical, like we've seen from Marta. And so Marta's asking about custom metrics, and I'm assuming that this is being applied to AutoML specifically. And so with AutoML, there's only limited metrics supported based on the task type. So we support regression, binary classification, and multi-class classification. And we have the objective metrics that are the ones like I showed that are there. We don't have any other metrics supported on regression, but on classification, we have those that were showed. If you wanted to do something like add a Gini coefficient or some other things, you can definitely do that, because as I showed, you'll have the probabilities and the predictions down the line. But that would be better to either code in, if you're like a SQL wizard and like SQL, like you code that into a beast mode to calculate metrics that way, or you could even code it into the Python or R tile if you have access to those. But that's more power user if you want those custom things. you definitely have that capability within Domo to do that. So not supported in AutoML, definitely possible in the platform with the coding functionality. And then the other question was, since AutoML, I'm assuming that both of these are related to AutoML, because we had a mix of linear and nonlinear models. Those that know data science know the root of this question comes down to the fact that in machine learning models, you also often have a trade-off between accuracy and interpretability. You either have a model that is less accurate or simpler, a linear model that can just learn a linear trend, but gives you interpretability into why it's making its decision or explainability. And then you have models that can tend to be more accurate, that can learn nonlinear effects in your data that tend to be less interpretable. They're called black box in many cases. And obviously, like, that's problematic because in most business applications, if you give any like decision maker a prediction, the very next thing they're going to want to know is why, right? They're going to want to know explainability. And so it's been a really high area of interest in the machine learning community of figuring out, like, well, how can we maintain accuracy and also maintain interpretability? And so for AutoML, what it's doing is it's using an explainer approach, right? So with a non-linear model or a linear model, you can explain that more complicated model with a simpler model. The specific method that we're using behind the scenes is called Shapley values, if you're really nerdy and get into that. But suffice it to say that there's a lot of work in recent years that has been done in explainability, and we're using a model explainer that produces the coefficients for all of the models. Now, with that, we only are producing the explanation for the top performing model because we have to run that process separate from model training. And so the rest of the candidates there don't have that explanation because it is a separate process that's running to explain the model. So that might be too verbose of a description, but that's your foray into machine learning explainability for the day.
Ben, and possibly I see we've got Nihar on the call. I would like to ask each of you if you can give a really, like, because we only have about 2 minutes left, really succinct answer. For the people who are either HighCode and are not super excited to use AutoML, or people who are just like, but how does Domo as a platform work in supporting my forays into data science? Let's assume there was no data science tools, but like just Domo, the platform, how does it help in that data science story? What kind of functionality does it provide? Does that question make sense?
Yeah, and so I'll take a really quick answer and let the other guys take a stab. I have a thesis that more impact is going to be had with simpler math and simpler approaches, and more time being spent on refining your data, cleaning your data, looking in your data for data artifacts, and making sure you really understand it and are working with the people that know it inside and out, right? So the upstream effects, like obviously Domo has a lot of tools to prepare and manage that data upstream of data science. And if you're HighCode, like, yeah, go ahead and use the data science tools like AutoML and scripting tiles or data science tiles, Jupyter, whatever you want to use, or take it off into any other service, take it off into a cloud, take it off into Databricks, wherever you want to take it. We have write back connectors and ways to do that. That's fine as well. Like we can be agnostic there. But then also you're going to need to have a way to communicate your insight to your decision maker, right? And so that's another place where Domo fits in really nicely. So that's my short answer.
I love that. Ben, do you have anything to add to that?
Yeah, no, look, I think some of, like, Ben's right. Like, it's like you can start simple. Some of it to me comes back to scale. Right? If we can, and it's obviously a lot of us end up dealing with like the edge cases of really, really big data. We have to figure out exactly how to use it and use adrenaline flows and all these other cool things that Nihar talked about yesterday as well. But at its core, the scale of Domo, certainly even when I was at Target, is just so much more. And so things like outlier detection, things like averages and benchmarking, and like some of the driver stuff you've done too, Jay, around like, you know, basket traffic, like some of those basics often get cut off or get less functional if you're over summarizing the data, right? So it's like, great, I know there's an outlier in this one division. Okay, well, which items, right? What can I actually act on? How can I make a change? And so part of it is like the scale will let us actually get more meaningful. I would say the other thing that I often see, and look, it's hard to prove, so people can poo-poo it, is that there is something very powerful. It gets back to the scale idea and even the idea Ben was saying about like, how do you communicate to business leaders versus the actual action, about knowing that there's alignment across your organization, right? The fact that like how a CEO is looking at their information is the same as an analyst who's trying to like change a forecast or update the website or whatever it is. And it's intangible, it's hard to measure, but I think that when you think about like, how do we change data culture, knowing that like you have sort of this common thread of smart insight and data across, can be really powerful versus, oh, well, you know, we're going to do the PowerPoint for the CEO and then someone else is going to do this. And it changes the culture, I think. So I've yet to find a way to measure that though. So, but maybe we could in some ways.
I love that. Nihar, what about you?
I can't top what Ben and Ben eloquently said. So I'm just
You
going
can't
to
top? Well, I mean, actually, Nihar, one of the things that came to mind that you mentioned yesterday was just how strong PDP is. And we, you know, a lot of times we talk about self-service BI, this idea of like, or even multi-fabric, the idea of that we can collect data from all of these different places, put it into one place, and use that kind of as this playground for people to explore the data, get comfortable with the data, profile the data, understand the ins and outs of it, Ben, as you were describing, Ben Ainscough, as you were describing. Like that's always step one before I can have a good data science project. And like, even if I don't do my data science work in Domo, like having that platform there for managing the data, creating data backups, recovery, disaster recovery, and all of that stuff, I think is very much undersold and undervalued in the conversation about Domo as a data platform. But
yeah,
okay.
I think we brief and so yesterday we talked briefly about where PDP is enforced, which is at the engine layer. So really, no matter what tool you use, so you could be using a CLI to cleanse your data, using our APIs. Ultimately, we are honoring what access you have at the engine layer.
Wicked. Okay, well, Ben and Ben, thank you so much. Nihar, thank you for jumping in at the last second there with your insight. Our last talk of the day is going to be with Andrew and John.